Hello everyone, and welcome to the Speculative Wildlife Research Center. It's certainly been a while since we last visited the planet of Sidus. But trust me, there is a good reason for that. I mean, it does take time for the little creatures to evolve. Nonetheless, they did, and so it is time for us to see their development. Let us begin with the general state of the world of Sidus at this point in time. The giant continent of Terra Centralis has begun splitting apart, resulting in the formation of two continents from it, Boralia to the north and Ostera to the south. Our researchers worked hard for countless nights to name them, so give them a break. Tall Lentarborea forests and increasingly wide carpets of Leucophagia covered the land, and, while still a minor concern given the great expanses of land available, they nonetheless risk overrunning the entire planet if left unchecked. Last time we visited this planet, some Lentarborea had developed the capacity to rotate and move their parts in reaction to external stimuli, and this would allow the formation of small, independent forms of Lentarborea which would slowly travel the land in search of places with high mineral concentration and good amounts of sunlight. This, however, would have been nary a curiosity, a mere footnote unlikely to thrive, if not for a new development. Death was born inside us. Do not let the evident dramatism of our wording fool you. There is no better way of explaining what took place in these lands. Long before the Metallosoma had developed into their modern forms, a small form of self-replicating crystal diverged from the phylogenetic tree. These early organisms were still very basal and undifferentiated, similar to the very first microorganisms, still lacking a metal shell and having a very open, undefined form. They would survive by passively absorbing minerals from their surroundings, until they developed the capability to release simple chemical compounds, small concentrations of salts obtained from their environment, which would allow the oxygen present in the air to corrode the metal and crystal that made up other life forms, with these microorganisms, now named oxymicrobia, utilizing the resulting minerals to reproduce. Before this, the lifeforms of Sidus had all the time in the world to do as they pleased. Their tissues could not rot. They ran no risk of starving or becoming ill, simply staying in indefinite stasis until they were capable of regaining access to resources or sunlight. However, the advent of death meant these organisms now had to race against time. Now only those who could protect themselves, or who could get resources, grow and reproduce fast enough to beat their own degradation into nothingness, had a chance of bringing new generations to the world. The rise of oxymicrobia kicked natural selection into overdrive, and brought forth the first great dying in the world of Sidus, but in doing so led to the evolution of new beings unlike any we've met on this planet so far. Spurred by these events, life on Sidus was forced to adapt. Some sessile organisms developed harder, stronger coverings that slowed down the damage done by oxymicrobia, while others would develop more complex bodies that allowed them to perform their biological functions before their time on Sidus expired. The constant increase in the biomass and complexity of these lifeforms would lead to the development of stimuli-sensitive crystalline formations, as a need to respond to the environment they lived in. Certain formations would, for instance, have components that reacted to the presence of certain molecules in their surroundings, to heat or cold, or to the presence of light, allowing the organism to be more efficient in its search and capture of energy and other resources present in its environment. Other, more fragile crystals, instead, have a very strong reaction to pressure, mechanical stress, or the detection of air molecules upon being exposed to their environment. These crystals have a very important function that would lead to very complex interactions between different organisms. Pain reception. Upon being damaged or exposed, these crystals would indicate to the organism that harm had been inflicted upon it, allowing it to respond in order to ensure its own survival. While at first this allowed them to avoid damage from attrition, falling, or contact with damaging substances, it would come to have a much greater function in time. And while their simplistic physiology worked well for the sessile organisms that once populated Sidus, this increasing complexity required a means for the transport of metals and minerals throughout the organism, and this was achieved through simple capture of external oil. The internal oil medium created would passively transport these particles, which would be used by the internal crystals to grow their structures appropriately. This also solved the issue of the ever-increasing energetic requirements of these mobile organisms, since simple light capture was not enough to move these larger bodies. As such, these organisms started, little by little, using this oil as a hydraulic system and as a source of energy. The most basic of these lifeforms are the ones known as oleofornax, the oil drinkers. As their name suggests, these organisms drink the oil present in their environment and, aside from its regular homeostatic functions, use it to actively power their bodies. Once ingested, this oil will pass through complex systems that would turn it into highly efficient biofuel, which generates greater amounts of energy than the simple uptake of light. While the feeding structures of early oleofornax were little more than immobile filters that absorbed oil through capillarity, the need to find new sources of oil led to the development of more refined structures that made the task of reaching, obtaining, and absorbing this oil easier, including faster and more efficient methods of locomotion. Presented here is the primitive but effective template for most organisms of this kind, a rotating axle with 3 projections, or legs. Furthermore, their sensing cells would become more numerous, arranging themselves in a way that allowed them to more precisely survey their environment. As the diversity of the oleofornax increased, many would adapt to new lifestyles where they faced little competition. Some of these oil drinkers would evolve sharper, grinding mouth structures over time, which were capable of cutting through the substrate in order to access sources of oil. It wouldn't take long for these organisms to turn their attention towards other oleofornax. After all, simply stealing the processed oil from another creature was much more efficient than processing it themselves, allowing them to reserve more energy and resources towards growth and reproduction. As they perfected this lifestyle, these predators would develop more specialized killing mouthparts, which could be used to break or penetrate prey tissues. In many cases, grinding structures would even allow predators to break down the metal that made up their prey, incorporating it into their own tissues. As these killing structures diversified, 2 large tendencies emerged in predators, with many groups becoming specialized on feeding on different types of organisms. The lensivores, for instance, would feed on the metallosoma and leucophagia, particularly on their light-catching structures, which were much easier to break down. The mechanivores, on the other hand, were adapted to catch and feed on other mobile organisms such as the oleofornax. These 2 groups, mind you, are not monophyletic. It is simply a distinction akin to that between herbivores and carnivores in our world. Eventually, the versatile mouth structures of these organisms, both lensivores and mechanivores, would allow these beings to diversify in order to feed on a huge amount of food sources. And these food sources would have to adapt in order to counter their predation strategies, leading to a steady increase in biomass and the development of increasingly complex structures and lifestyles. As the macrobiotic era approaches its end, 2200 million years after the planet's genesis, Sidus's plate tectonics will finally break the land into the now fully isolated Boralia and Ostera, allowing life to evolve in some truly remarkable ways. What can I say except thank you all so much for being here for a new episode of this series. It was really great seeing people excited about the continuation of my World of Metal project. And even if it took a while to get back, now we're finally back on track. And as promised, here is the point where life really starts going crazy. With prey and predators now running around Sidus, things will truly begin going off the handle in terms of crazy anatomy and adaptations. Will we see coral formations with laser beam turrets? Will we see buzzsaws being used to hunt huge living fortresses? Will we see Lightning McQueen as the apex predator of this world? Tune in next time to find out. I hope you liked this episode, and thank you all so much for coming back and asking for more of this series. And also big thanks to our patrons and channel members for their support, and a welcome to our new patron Brodo Baggins. Remember, you too can join in if you want to support our channel, and you get some nice bonuses too, like seeing all of our creatures and videos ahead of time and helping mold them into shape. And if you want to see more of this series, or if you have any ideas of how life on Sidus may evolve in the future, please let me know in the comments below. And if you'd like and subscribe to the channel, that would be pretty metal of you. Thank you all for watching, and see you next time on the Speculative Wildlife Research Center.